This video describes one way of connecting the various components of PiTrac, including the cameras, PiTrac connector board, and the Raspberry Pi itself, together into a working system. And of course, we want to make sure people understand the purpose and scope of this video and the potential risks and dangers that may be involved when we're working with electricity. And for that reason, we are presenting this informative prefatory message, because people. To start with, let's not bury the lead here. If you've done small projects like this before, really all you need to do is just mount up the various components like the camera and the Pi and the connector board and get them wired up in a safe, reliable way. And to do that, you probably just need the wiring diagrams, which I'm presenting right here. However, a lot of people would like to see a full video of how this comes together, so the rest of this video is an example of how I put together one particular PiTrac. Your mileage may vary, your components may vary, you may have to make some changes based on that, but this is just one example of how I've done it. The first step is going to be to mount the Pi 5 and the version 2 connector board onto the PiTrac tower. We're going to do that with a set of 4 M3 by 6 cap head Allen screw bolts, and that'll be for the connector board on the bottom, and then on the top for the Pi we're going to be using M2.5 by 6 millimeter long bolts that will also be the Allen cap head bolts. When you are finished mounting the Pi 5 and the connector board, your tower should look like this. It's time to make the wiring harnesses for the connector board and the LED supply, the LED light and the Pi. I'm going to use these heat shrink wire connectors, which honestly you don't need and might even question, but I thought it would look a little cleaner. I've had to modify some of these little connectors to better fit the portions of the board like here that have the screw terminals, which are fairly small, or for that matter the screw terminals here on the meanwhile supply, which were also a little smaller than the original size of these connectors. Probably the main thing you want to consider here would be to just make sure you have really tight gap-free connections between any of the higher power elements. You want to make sure that you don't have any kind of arcing or anything like that if the connection is loose. Hopefully these will work well for that purpose, but really honestly, if you have something like 18 gauge wire, that's going to work just as well. There's some good videos online to tell you what the best practice is to connect wire like that to these screw terminals. The nice thing about copper wire is it'll squish down and probably have a better contact, possibly even a better contact than using these hacked little screw connectors. Unfortunately for me, I only have 24 gauge wire handy right now. And this is a running joke on the Discord, I'm probably going to use some more of my Radio Shack speaker cable, which is 18 gauge. So I'm probably going to use that to wire up the power supply here to the connector board and the connector board to the LED light. Again, we also need to go from the AC plug-in connector, which is going to go here, to the line, neutral, and ground section of the meanwhile power supply. So this is the setup I'm going to use for that. You'll also note that I'm planning on using some of these ideal power plug connectors, which look like this and are well marked on both sides. These are nice because they just snap together and all you need to do is just push the wire into here, and there's no soldering or clamping or anything else. These basically just are one-way connectors for wire. And these work really well. They're certainly not necessary, but I've got a number of different PiTracs right now, and I only have a few things like power supplies and such. So it's easier for me to use these quick connect plugs so that I can kind of mix and match between the relatively small number of parts that I have and the larger number of PiTracs. Hopefully that'll make it easier to swap parts out. In terms of the lengths for these wiring harnesses, you just have to remember that the Meanwhile power supply is going to sit, there's two mounting holes here. It's going to sit near the back of the base box. It mounts through one hole here and two countersunk holes here. Actually, that one's countersunk as well. So in terms of the harness wire length, most of them just have to go either from the plug here to the inputs of the power supply, the AC main inputs, or from the 5-volt output up through this hole and into what will be the bottom of the tower. So they don't have to go very far. And then finally, we're going to have some wiring from the LED driver strobe LED output here to what will be an LED sitting here. So that's not going to be a very long wiring harness either. The final part of the wiring harness is going to be from the GPIO and SPI outputs of the Raspberry 5 here to the strobe triggering input and power on the connector board. For that, you can just use individual cables like this. You can find them online in kits that have a bunch of them. They're also good for breadboarding. Or my preference, if you have it, is to use some sort of ribbon cable like this, just so everything kind of stays together and looks a little bit neater as between here and here. So let's complete our wiring harness. Again, you probably don't need any of this at all. Just these wires would be plenty sufficient to connect between the screw terminals here and the screw terminals on the connect board. I'm just doing this because it makes it easier for me to swap parts. So I'm using 18 gauge speaker wire. That's probably about right. I have some 22 gauge, but I don't think that's going to be enough for the mains, especially at, or for that matter, the 5-volt 75 watt supply coming in. 22 gauge is probably just a little small. So let's just strip these to about 1/4 of an inch. That should be enough both for the screw connectors and for these. You probably would have to go, I'd say about 1/2 of an inch, maybe even a little bit more, if you're just connecting these wires directly to the terminals, which again is just fine and maybe even desirable in some respects. You definitely don't want to solder these. I've seen some people try to put solder on these and then put them into some kind of a crimped connection. That's actually bad because the solder doesn't necessarily make as good a connection as just the raw copper. You do probably want to twist them a little bit, especially when you're going into these things, because otherwise sometimes they can bend instead of going in straight. So again, about 1/4 of an inch is what I'm going to use here. With respect to the screw connectors that I'm using, the actual part that gets crimped is just this little portion, let's see, right in here that you can see sort of above my fingernail, and it's not even 1/4 of an inch long. In terms of the length and positioning of these wires with respect to these screw connectors, you want to have enough clear copper to connect within this area here. You don't want so much that it's coming out where my thumb is right now. ground, neutral, and hot AC main lines that are going to go from the plug connector that will sit here into the 3 inputs on the power supply. Next, we're going to go from the 5-volt outputs of the power supply to the 5-volt inputs of the connector board. All right, and this wire is going to be used to connect the 5-volt, sorry, not 5-volt, the constant current output, which probably is around 20 volts, for the strobe light into the strobe that will be sitting here. So with that done, we're going to use, I like using the speaker wire simply because it has the wires that actually hold together over some distance. You don't have to worry about the wires kind of going separate from each other, and because one's clearly marked with a color. I'm using something that's not even really supposed to be used for this, but I found it works reasonably well. So you just crimp. You only want to crimp once. The trick is to make sure that you get it right the first time. Now that we've got good, solid connections between the screw terminals and the wires, and again, this is something I don't think I'd recommend for most people, it's just sort of my special case here. We're going to turn on our heat gun and heat shrink the material around the wires here. One thing you have to keep track of here, and especially in the case where I'm using connectors where we might be able to cross the wires, is you got to make sure you keep track of which polarity the wires are going to be. Like in my case, I just happen to know that the connector on the existing PiTrac board that I'm building this harness for has the positive side for the LED strobe here and not here. Obviously, get that wrong, you can blow up your strobe light, or worse. So just triple check before you that takes care of our wiring harness. We should be ready to wire up almost everything. The only last thing we need is we need to pick 3 wires that will take care of the connection from here on the connector board to the correct pins over here. So for that, we've got a 3.3 volt high, a ground low, and a strobe. So if I have a connector here where I've got some reasonably decent colors, like for instance using a red for high and maybe brown for earth and orange, I think that'll work pretty well. So I'm going to use these 3 connectors here. I wish I had a slightly shorter cable. Doesn't seem to be the case. Yeah, maybe this. Okay, we'll use this. These connections here are just perfect for both the pins on the connector board and the GPIO pins on the Pi. So I'm just going to strip off these three. We're going to use red for 3.3 volts, brown for ground, and orange for the strobe trigger. And with that, we should be able to wire everything up. Please note that when I first filmed this particular video, I actually had the neutral and ground wires reversed, so it's pretty easy to do for anyone. The setup that I'm eventually using is shown here in this image. The wires in the video may look a little bit different because I ultimately ended up replacing the wires with a 16 gauge stranded wire and had to reverse the mistake that I had made. You want to torque these down fairly well to make sure the connector has really good electrical connection. There won't be any chance of arcing or something like that if the cable were to come loose. Before we put the power supply into the base box, we want to make sure that it's wired up correctly and that it's connected up correctly to what will be the AC power source here. First, a caveat. This particular power plug module came wired like this with these colors, and I have no idea if that's the sort of standard way of doing it. It didn't seem right to me, but I went with it just because that's the way they had wired it up. The critical thing here is you got to make sure you understand which of the three inputs are which. Generally the one in the middle is going to be ground, but you know, I'm not even going to try to give folks too much advice with this because each situation is going to be different. Your power supply may be different. Your colors here may certainly be different. In this case, I have these two wires as the output for the power supply, and I have, somewhat unfortunately actually, I've got the AC live, which I'm going to mark as L right now. I've got the live AC on one connector and neutral and ground on another together. Probably would have been better to have live and neutral paired together in a connector. I think that's more with best practices, but it is what it is here. The key thing is just to make sure that this says L or live connected to L. The neutral here, which is the non-white wire, is going to neutral here, and ground, which is the white wire on the speaker cable, is going to ground. And then we got to make sure that we've got things plugged in the same way from our power supply. In fact, I had these two backward, I believe, earlier, which probably would have resulted in a blown fuse if we had hooked it up. In any case, we now have everything, I think, connected correctly. I'm going to turn on my voltmeter here from the early days of Radio Shack, although it still works just fine. And let's make sure we're not shorting anything. It looks fairly secure. We're showing 0 volts right now. correct, of course. So now I've got a live AC power source here. In this case, it's 120 volts. We're going to try to connect this a little more consistently. There we go. Okay, so as I plug this in here, we should see this light come on and that go to 5 volts if everything's plugged in correctly, which looks like is the case. Okay, so we've got 5.1 volts about coming out. There's no smoke, nothing looks hot. So we're going to call that good and go ahead and mount the power supply into the base box. Please note that there's a fairly big capacitor in here and that it's going to hold some energy. This power supply will, even after being detached from AC input, will probably hold supply for, I don't know, it could be a good 30 seconds or so. So you want to make sure that you discharge that energy in some safe way. For instance, you can just hook your voltmeter up to the 5-volt output and wait a half a minute until the voltage goes down, which I've already done. But just make sure the power supply really is completely off, the green light is out, and there isn't any voltage across the supply output. So to connect this to the base box, there are 2 holes on the bottom and 1 hole here on the side that corresponds to this side, and these 2 holes on the bottom. Note that these holes here, as well as here, are very close to some of the components of the part of the power supply. So if you can see here, you don't want to have a screw that goes high enough that it'll touch or even get anywhere near the PC board. So we're using fairly short screws here that have just enough length to get through the base box and get a sufficient amount of purchase into the sheet metal of the power supply. Again, these are M3 6 millimeters. It's a little easier to see the holes in the power supply. You do not want to over torque these screws. The chassis of the base box plastic is pretty thin, and it only has, at least in this case, about 15% infill. So just be real gentle. You just want to get the screws in enough that the power supply is secure and such that the countersunk screw goes into the countersunk area and you have a decent flush surface, especially here on the bottom. All right. Before we get much further, we want to make sure that our power supply is working. If you haven't already tested this with the power supply out of the box, now is a good time to do so. What we're going to do is we're going to hook up the side of the case, the cap of the base box, to 120 volt wall power, and at that point we're going to plug these into these and test the power across the 5-volt output. So we've got ground, which should go here. Good. We've got neutral here, yellow, which should be N, red going to the line. All right, so got that. Let's get our multimeter hooked up, and make sure we don't short anything here. And finally, we're going to plug in our cap. Now, we're plugging in 120 volts, so make sure that these are secure and that you are not anywhere near touching any of those when we plug this in. Plug in our 120 volt power. So at this point we've got power supply mounted, and the next thing to do will be to mount the tower, or at the very least connect the tower so we can start doing some initial testing. So for this, I'm going to mount our cameras and our LED strobe light first, because ultimately what you're going to want to do is you're going to want to be able to tighten, for instance, the bottom camera here with a nut that will go into the mount for the camera, and you can't do that very easily when this tower is mounted to the base, because there's just not a lot of clearance here where my thumb is. So you want to try to get all of the cameras and the LED mount, the LED strobe, sorry, in here, probably before attaching this to the base. So we're going to wire up and assemble the rest of PiTrac here. As a prerequisite, you should have your Pi and your connector board mounted, power supply already wired up and tested and mounted to the Basebox. You should have your wiring harnesses to the extent you need them. Again, some simple wires will probably work just as well. This is probably way overkill. Although the keyed connectors here do help me save myself from myself sometimes. Next, you're going to have your strobe all set up, soldered together with wire leads already connected. You certainly don't have to use a connector like this, but you should at least have your wires with a fair amount of extra wire already soldered and ready to go, so that you don't have to do anything else to this mount. Both cameras should be mounted in their mounts. It's much easier to connect the ribbon cables now. So I've done that. You want to make sure you've got the ribbon cable connector here locked down so that the connector won't come out easily. This is the camera 2. This is an Innomaker camera, as a matter of fact, and you can see we've got a ground and an XTR trigger, external trigger cable already connected. We're going to use these to connect to the GPIO outputs of the strobe. So one other thing to note is that I still have the previously suggested bits of tape both here to prevent the base screw from falling out, and also here and here to prevent the side screws from falling out. You never know when you might have to undo this, and when the bolts fall out, it can be really hard to get them back in because there isn't a lot of room in there. So get them in, put the tape on, and when we're finished with the project, we can pull the tape off and make it look pretty. So I have both cameras ready to go. I've kept the caps on the cameras because otherwise you end up with fingerprints that are hard to get off the lens. We're not worrying about focus right now, we'll do that later. Again, this is the top camera, so it doesn't have any external trigger connections to it. And we've got the, in this case, a somewhat shorter, oh, I take that back actually. We've got the same length cable for both. This is, I think, 30 centimeters, a little over a foot, and probably too long for what we want now. I'm going to keep it like this just so we have a little more room to work and twist these cables. It's quite possible that, especially for the top camera, which is going to be mounted here, you'd be able to do a much shorter run to this cable connector. So that's the prerequisites for putting all of this together. And let's get started. After a little more thought, actually, I'm going to put a 15 centimeter cable on the top camera and leave the 30 centimeter cable on the bottom camera. Two things to be careful of. First of all, these MIPI connections are great in the sense that they're very compact, but you also have to be very careful to make sure that you push down this this back plate that snugs the cable against the contacts. It's very easy to not quite get that all in and then have the cable come out later, and then you have to remove the entire camera to put it back in. The other thing to be careful, of course, is just make sure that you know which direction the contacts, the copper contacts, need to go. In the case of the Inamaker camera here, the contacts go against the board, so they're on this side. Let's see, they're also quite fragile, so you can't fold them. You can bend them somewhat like we have here, but too much bending or any folding tends to break them. Using some tweezers like this and a magnifying headset is useful for connecting the MIPI cables. So with that, let's start by connecting the top camera. And the reason we're going to do that is without the bottom camera here, or the strobe here, it's easier to get this camera in place and tighten the bolt at the bottom. So we're going to start from the top and work down. So again, I have my screw taped into the recess here, so even if I push the screw up, it won't come out. Cameras and strobe light mount with M5 bolts. These are bolts that have a hex head. These are M5 by 12 millimeters in length. When you mount these, you want to make sure that the ribbon cable doesn't get pinched up here between the top of the camera and the top of the base. You can see there's not a whole lot of room in there, so be mindful of that. The camera should be pointed downward because this is a camera, the camera one that's going to be focused on the teed ball. And if we look here, I think we should have enough space to get this ribbon cable to connect to the Pi board, just barely enough. This camera wants to be straight out, so you're going to want to get it as close to centered as you can, and then torque down the bolt that's holding the camera mount pretty hard. We really want to make sure this doesn't move, shift, and it's a lot easier to take care of this this type of thing right now. If you can get a small hex wrench in there, that's great. If you don't have a right angle hex wrench, you can use some pliers, and just make sure that the camera is pretty tight. It is possible to crush these floors, but you just want to make sure that the base mount doesn't come undone. We'll tighten up these side screws later. For right now, they seem to be holding steady. And again, just make sure that the camera is facing straight out the front. We're not going to connect this quite yet, but we can see here that because the copper connections are on this side, we're going to have to twist the cable somewhat in order to get it into the first slot. And this camera will go into slot 0. So camera 1 will go into slot 0, which is the one closest to where the cable is right now. And I think we have just enough room there. Next, let's connect or mount the strobe light. Again, the nice thing about having a tape here is you can just take the bolt out. We have a lot of extra cable here. It's really not necessary at this point, but because I'm using this strobe in different versions of PiTrac, I am going to retain this additional amount of cable, even though it's going to look a little ugly, and even though it's going to take up some room. For most people building this, I think probably a 8-inch cable would be plenty long enough. If you recall, we earlier set up the other side of this wiring harness to connect to the connector board here. Same thing here, you want the strobe facing straight out, and you want to make sure that the strobe's mounting bolt is pretty torqued down. You can see here we have all this additional wiring. I'm going to do my best to tuck it behind the strobe later. Note that the strobe, of course, is going to be focused at least somewhat upward, because that's where the shot is going to be generally going. Probably not focused that far up, maybe more like this. We can get that straightened out later, but at least for right now, we've got this at a point where we should be able to connect it to the version 2 connector board here. All right, make sure it's straight and finalize the mounting bolt tension. All right, now ready to put in the camera that's going to take pictures of the ball in flight. Put everything through there. This, I think I'm going to try to route up here. Again, maybe we could use a shorter cable. If we find out we can later, I'd be happy to disassemble this part and deal with it then. Okay. One thing to note about this is that, as you can see here, there's not much room between the bottom of the tower and the top of the base box. It's just this little place where my pinky is right here. So it's pretty hard to deal with this bolt later. So you really want to make sure you've got it where you want it now. And this camera will be usually tilted just slightly above horizontal. Okay, I've got that camera facing straight out, which is a good default. This is where we're at right now. So here again, with this, we're going to have to twist the cable, because the Pi 5 wants to have the copper parts of these MIPI connections facing toward where the Ethernet port is. So in some respects, it would have been easier to have this upside down. That might work for you. The main reason we have it here is just so it's easier to connect the Ethernet cable and possibly a keyboard or a mouse if you need it from over here. There wasn't a lot of room down here. So next, let's very gently pull up each of the MIPI cable securing bits of plastic. You can see here, hold this up, these are very delicate. If they break, it's kind of a pain. So you want to get these so that they're raised up about a millimeter or so above where the mounting cable is, and that should allow you to then put the cables in. I'm actually going to use some magnifying a magnifying headset to get these in, and a pair of tweezers to help push. Note that the camera MIPI cables for the Pi 5 are different than those used in previous versions of the Pi. This was a larger format version used in, for instance, Pi 4s. And this is still the same version that goes into the cameras. So if you see here with a Pi 5 cable, we have the same connection that goes to the camera. However, on the side that connects to the Pi, instead of having this, we have a smaller format with additional pins. So you have to make sure you get the right type of cable when you purchase your cameras. Very often the cameras will still come with these old style connectors, which are not useful for the Pi 5. Just remember that you want the gold pins to be facing where the Ethernet port is, so facing that direction when you connect these. As you're connecting them, you want to hold the cable with a little bit of pressure into the port to make sure that you don't shift the cable left or right or allow it to pull out a little bit before you have a chance to push down the connector securing clip. You can do this with your fingernails. You just have to be really careful that you're pushing down both sides evenly, and that ultimately in the end the securing clip is completely down against the MIPI port. Looks like we've got that happening with this. The result looks like this. If you look carefully here, you'll see that I failed to really get this particular cable in straight, and instead it's coming in a little bit angle like this. So we're going to have to redo that. And for whatever reason, it seems like I struggle to get these perfect the first time. It always takes some additional work. We can try this one more time. I think I've got that in pretty well. Now it looks like it's straight side to side. This camera that goes to the camera cable that goes to the lower cable. Next, we're going to want to deal with this additional length of cable at some point. But for right now, we're just going to let that hang out. I believe you can also buy cables that have the gold on the other side or that have gold on both sides. That would be handier for something like this. You'd probably get a much cleaner setup. I'm not going to worry about it right now. Next, let's connect the strobe output, which will be coming off of this part of the connector board. Right now on this LED, I should have marked plus or minus, but this is going to be the positive connector here. I just know that because I've worked with this connector before. You can see I've got the wire with the white stripe on it connected to the part of the connector here that doesn't have the black ring around it, and that means that I'm also going to have the white stripe here, which is connected to the red positive once we put these two things together. Let's get it first set up. For this, I think the easiest way to do it is going to be to bring the cable through this top port here. And although it would make sense to have this cable come out. Let me get this other one in here. It would make sense to have the cable come out this direction, at least intuitively, but the problem with that is this is where you're going to want to insert your SD card. So we want to keep this area as clear as possible. So instead, we're going to bring this through like this. So let's connect these two to the board. Another problem with these screw connectors is that you need to pull these little screw compression plates completely off of the screw post in order to get things tied down. You want to make sure that the screw is tight enough to compress the part of the screw terminal that's going to contact the metal. Now the question is how best to connect this. I think for right now, I'm just going to connect this over here. It looks a little messy, and then just shove it all back in behind the LED strobe, assuming we have enough room to do that. One thing I just did, by the way, was to push the back of this down, which of course could possibly compress this cable. So I want to make sure we're not doing that from this point forward. Okay, well, this is far from ideal, but it'll work for now as far as the strobe power goes. Next thing we should do is figure out where we're going to connect our two trigger and ground cables from the camera that's going to be externally triggered, the camera that's going to be watching the ball in flight as it's getting strobed. And these have to come up to here. And as you can tell, we've got, I think, just enough length to make that happen. I would suggest something a little longer than 8 inches if you're going to be running a single cable. I wish I had given myself a little more room here, but it is what it is. We can add more cable if we have to. Okay, there we go. I think that's going to be just enough space to connect these to the GPIO. Now, it's very easy to connect these incorrectly to the rest of the system. Pins aren't visibly numbered on top of the board. You have to make sure the board is oriented the right way and that you're counting the right way. And so I'm going to put on the screen here in just a moment a diagram, which is also available in the documents, showing which of these outputs these two cables need to go to. So I've hooked up the external trigger wire from the camera 2, which is the white wire here, to pin 19, and I've hooked the ground from that cable up to pin 20. We also need to hook up the output of the actual power output, doesn't really matter which one, to the Pi. And so we're going to do this here. It's a little tighter than I would have wished, but that's the way it is. So that is going to go to the Pi to provide power for the Pi. Again, not sure I like that. I did have a 90-degree cable here, which I was going to use, but I can't find it right now. In any case, this should be okay for the Pi currently. So the last thing we need to hook up from the GPIO is going to be the inputs to the connector board, and this is going to be the input that's going to provide the strobe as well as the 3.3 and ground reference power from the Pi. I've hooked up the ground wire from the camera to pin number 20, which is one of the mini grounds here on the GPIO, and the pins go 1, 2, 3, 4, 5, 6, and so forth. So directly to the right, the way we're looking at it here, pin 20 is going to be pin 22, and pin 22 is the also known as GPIO pin 22 or GPIO pin 25, but it's pin 22 if you're counting 1, 2, 3, 4, 5, 6, and so forth. So that is going to handle the shutter, the external trigger for the shutter of camera 2. Next, we're going to hook up these 3 connections here on the connector board. That's 3.3 volt and ground references from the GPIO, and then a strobe signal, which will be coming from the GPIO pin number 10, or it's also called the MOSI, and that's going to be pin 19. So we're going to use the orange cable here, and by the way, these cables came from another ribbon cable like this. It's easy to just get a big group of these, and then you can use them together or separate. They're relatively inexpensive. So we're going to put the strobe output of the Pi on pin 19. Right under the ground pin that we use for the camera. And then 19 is going to go over here to the strobe connection. We're also going to run another ground from the Pi to the connector cable. In this case, we're going to use pin 6. I'll be using the brown cable for that. Black would be better, but 1, 2, 3, 4, 5, 6 puts it right here. Hopefully you can see that. From the camera, this is where we are so far. So brown is going to go to ground over here on the connector board. And finally, the 3.3 volt connection on the connector board. Make sure these are all down. The 3.3 connection is going to go to pin number 1. So pin number 1 is the way the camera is looking at it's in the lower left over here. It's really easy to get off by 1 on these, so double or even triple checking makes a lot of sense. So at this point we have the shutter output from the Pi going to the shutter input of the camera with a common ground line, and we also have the MOSI, which is a high-speed data port actually that we're using to drive the strobe. That is on pin 19. That's going into the strobe input of the connector board, and then we have 3.3 and ground hooked up to pin 1 and pin 6 respectively. We can deal with making this look a little nicer later. We can probably get some zip ties and use these holes to pin it down, but for right now, let's leave this as it is. Next, we're actually going to connect the tower to the base port. Before attaching the tower to the base box, we're going to do one final connection of the AC input to the power supply. Just double check to make sure everything is still okay. Right now, I'm going to, you can see these connectors are keyed, so you can't put them in the wrong way. I'm going to very gently lead the AC power supply cables in this space here within the base box. You want to make sure nothing has any sharp bends. You also want to make sure you don't do anything to disturb the connections to the power supply. There should be plenty of room to make this connection without forcing anything. So there's that. I'm going to plug in the power supply one more time and make sure we've got a good voltage coming out of it, because we're about to hook it up to our connector board and ultimately to the Pi. This isn't the best way of doing this, but as long as I keep those two outputs from touching, it should be fine. Bring this over here. So let's make sure we have a 5-volt output, which we do. That's great. And then I'm going to use a couple of small screws. You can preferably use a countersinking screw here and here to secure the base plate to the rest of the base box cap to the rest of the base box. You're going to secure the base box end cap here to the base box with a couple of M3x8 flathead screws, and so these screws are going to have a angled top to them, which will help them sit flush, because we've here got a countersink screw port on this side and one on this side to keep that flat. We'll probably have to get into the box again at some point to attach the LED lighting on the front, so I'm not going to screw this all the way in. Next, we're going to take a couple, actually 4 flathead M4 screws. They look like this. These are M4 by 12, and we're going to use these here, here, and here and here to secure the tower to the base box. This can be a little difficult because the screwdriver ends up getting really close to the tower. It helps if you have either a very long screwdriver or one you can easily manipulate from just one side. Before turning on the system, we're going to connect a few things. We're going to start with a hardline connection, just in case, to the network, just in case things on the wireless side aren't working. We type the password in wrong, something like that. We're going to hook up a mini HDMI cable, doesn't matter which port you go into, to a monitor. And finally, we're going to hook up a mouse and a keyboard. At this point, you want to turn your PiTrac on and see how it works, and that's great. However, one of the more potentially hazardous parts of PiTrac would be a situation where the LED strobe light, which is a 100-watt strobe light, is on continuously instead of just strobing for a few microseconds at a time. To prevent this, make sure you disconnect the power to the strobe, to the LED, the 100-watt LED, before you turn on your PiTrac for the first time. Later, in a controlled environment, once you're sure most of the things are connected up correctly, at that point, you can turn the system off, connect the wires to the strobe light, and then while you're watching the strobe light from a safe distance, let's say a couple of feet away, you can start the system up and immediately check to see whether you're feeling any heat from the strobe light, and or if you're seeing a dull red light, which, because the strobe light is a infrared light and gives off most of its energy in a spectrum that's invisible to humans, it won't look very bright, but it could still be consuming 100 watts of power. And you don't want that. If there's some miswiring that would cause the strobe light to be on full time, you need to immediately turn off the system and figure out what went wrong. Typically, it's a miswiring of either the connecting board or the inputs to the connecting board, such that the strobe light, which is only supposed to be on when PiTrac is running and only for a brief instance, is instead on the whole time. So protect yourself and your environment, and make sure that when you start up PiTrac the first time, that you don't have the LED plugged in. Once we're certain that the system is working well and can be connected to remotely, we can forget about these things, and we can just connect to it remotely from that point on using tail scale or just putty or secure shell, something like that. But for right now, let's turn on our monitor. And plug in the Pi. I don't have the power and the extension cable on yet, so this should immediately turn on. All right, so we're going to be wanting to watch for a light, which is going to be a little hard to see over here, but there's a light just here at the bottom of the card as we have it oriented near the SD card. And if that starts blinking and turns on, that's generally a good sign. So here we go. We're going to turn it on and see what happens. The light's red currently. It should turn green in a moment, which it has. At this point, I'm hoping that we will see something on the screen shortly. That was just me. I don't see any signal yet, but hopefully there we go. All right, this is what you would expect to see when a Pi boots up for the first time. This is a brand new, freshly created SD card, so there's very little software and nothing from PiTrac that's currently on this Pi. Generally, the first time a Pi boots, it may boot a couple of times when it first sets up. Usually takes a few minutes. Once that happens, a desktop will come up, as we see here, and at this point it notes the power supply is not capable of supplying 5 volts at 5 amps, so power to peripherals will be restricted. That's okay because we don't have peripherals that are being driven. And it says that we're currently hooked up to a wired connection, which is great. The other question is whether or not we have a wireless connection. And looks like we have a wired connection, but no wireless connection, so we'll have to look into that. We open up a terminal, and I'm going to make it a little bit larger here. If we do a cat / etc. releases, it's called OS releases. You can see this is version 13 Trixie, the operating system, and we ought to be able to ping google.com or something like that. Yeah, we can. We can also ping our gateway. So that all looks pretty good. And finally, if we do a uname, uname -a, it looks like this is called RSP11, which is also what we're seeing on the prompt. So looks like we've got this set up correctly. The next thing is to make sure that we can connect to it remotely, and that was an option that we set up when we generated the SD card. So we're going to test that next.